lab.
Okay.
So is it going to
This
give
is lab
you
6.
like to set it to 10
Lab 6.
kiloohms? Or?
They may be set incorrectly. You may have to choose the correct range.
Okay.
So you
The way you
measure
choose that
the
correct range is you
resistance,
find the overload position.
the resistor, 1, 2, 3 across, and you
So
report the
always
numbers.
go to the overload. Like,
Yeah, that just means that there are too many digits for the meter to display. So you want the most digits you can get.
so it's not going to be something
And then for
that's
the
given
voltage meter, you're
automatically
trying to get it
to
to
overload
K.
position and
Get into
That's how you
ohms.
verify that it's
Okay.
correct. These two, this one here and this one, are going to look a lot alike. And actually, for this particular one, because we're in the 10 kilo ohm range, that's a 5 point something, that's a 1 point something, this is a 0 point something. You could go down one and add an extra significant digit, or you can keep it the same as the other two because you're going to be doing the math with the other two as well.
yeah.
That extra digit really won't help. So then you're asked to wire the resistors in series and then in parallel and measure the series resistance and the parallel resistance. But because this is a practical and because you've already had a lecture, you know what those values should be, right?
Yes.
You should all be nodding your heads. What's RS?
Just add them together. R1 plus R2. And that's 1 over R1.
1 over RP, 1 over R1. Don't forget this part. That's important. If you write RP, that's something measured in ohms. If you write 1 over R1, that's something measured in 1 over ohms.
This is lab 6.
Okay. So you get direct measurements. If that's 5.5, that's 2, and that's 1, what should your series resistance be?
You add them all, so it should be 8.
Should be close to 8. So now, wire them in series and test it.
Yep. It's about
Right.
8, yeah.
So, if you know what it's supposed to be, and it doesn't read that, it means you've made a mistake here or you've made a mistake there. And that's what the index
Always
card's
going
going
to be 8? Is that just like something?
No, each of these resistors could be different. It could be 222 on
Okay.
exam day.
Got it.
Probably you give us like another circuit board, like different values.
Is it? How do they set that? Is it just a different circuit board, like a different resistor?
It's a
on
different physical resistor. These little guys with the bands, you can read off the resistance either by measuring it directly or if you know what the color code means.
Oh, okay.
We do have a couple of electrical engineers in the class. Last question, why can't I just read the bands? It's like, you can. That's fine. Nothing wrong with that. If you know the code.
Oh, so you could just teach us how to read the bands.
Yeah. So this one is going to tell you it's a 5 kilo ohm resistor, but the direct measurement of it tells you it's a 5.4 kilo ohm resistor. So you can get that first digit. You can know about how big it is.
Oh,
But you're not going to. This color code doesn't give you all these significant digits.
Okay, gotcha. So now you're gonna measure in parallel.
So now wire them up in parallel. I think the lab calls for R2 and R3 in parallel. And that's all 3 in parallel. And how do you measure the resistance? That's probably right. I don't know what the math tells you.
Wait, what is it?
1 over 5 plus 1 over 2 plus 1. Right? What's that?
Yeah, I did the math. It's 0.66.
Oh, okay. That's close, right? Relatively.
Wait. Oh no. Yeah. It should be right. When I did it with Tom, it was only resistor 3 and 4, 2 and 3.
You want 1 over
Yeah.
1.8. What's that? A little bit bigger than half.
So that's
Perfect.
good. Yeah.
Okay, perfect.
Yeah. This is the kind of check you should be doing in your head or on paper. Okay, Kirchhoff's laws. Loop law, node law. Loop law means the voltage drop across all the resistors in series should add up to the total voltage drop across the whole circuit.
Okay.
To test that, you're going to pull the voltmeter out of the circuit. And you're going to wire up one in series with 2 and 3. You've calculated the value of RS already. And then you're going to return here.
Do you have to have them there too, or no?
This is series.
Oh, that's for series.
This is to check the voltage loop law. So if we apply some number of volts across the whole circuit, then the drop across each resistor should add up to that same number of volts. To measure the voltage across the whole circuit, use your voltmeter and you put it across the beginning and the end of the circuit. Where is the beginning and end of the circuit located?
Here and here.
Almost.
Oh,
Right.
This is what's providing the power. This is where the power is returning.
okay.
The whole circuit starts and ends here. So you'd measure the voltage here and here. It is basically equivalent to measure it here and here. The only difference is the length of these two wires.
So
You're
that-
not going to add significant resistance. You won't get a significantly different value. Both places are okay. This is usually easier because you don't have to mess with any of these wires. So that's on. This is down. Let's provide, I don't know. You're doing DC voltage.
One of my things don't get it. Can you send that to me later?
Huh. Yeah, sure. If
Let's
I
say 5
can.
volts.
Let's see.
So the total voltage across all of these should add up to 5. So what's that?
3.2,
What's this?
1.1,
And what's this one going to be?
0.5.
You can add them all up.
Some are negative, some are positive.
That's because I flipped the direction. The current's running through the resistor this way, it's running through this one that way, it's running through this one this way. So to get a positive number, you need to flip the order of the leads each time. I didn't.
So you're supposed to you add them all up.
You add them
So
all up.
1.3 plus 0.5 is 3.7 plus 1.2 or something
I
should
think
be 5.
it was 3.2. Yeah.
3. Yeah,
It
5.
works out. Similarly for parallel,
So in that case, you want the first one to be positive and then the next two negative?
no. For voltage, they should all be positive. The voltage drop is always a positive number.
Okay.
I didn't bother to flip the leads because you know you're going to add them all up.
Okay, gotcha.
For current, though, for the loop law setup, there are a lot of nice ways to set this up with the amp meter. Because what we want is to measure the current after it leaves R1, before it enters R2, and before it enters R3. That means we want the amp meter in series here before it enters R1, or here after it leaves R1, but before it gets to the parallel setup. So we would replace either of these wires with the amp meter in series. And for R2 and R3, we would want to measure it here before it goes into R1 and here before it goes into R2. You can think about it like plugging the amp meter in along one of these wires. But the way we have the circuit board rigged and the procedure written, there's an easy way to do this to take all 3 readings right away. Okay? So that's the low end of the amp meter at the node. That's where the series resistor joins the parallel resistors. Your high end of the power goes into R1 just like before. Your low end is going to come out over here. And then your high end of the amp meter in series, in succession, will go here, then it will go here, then it will go here. So, to measure DC amperage, we're going to see a positive number, then we're going to see a negative number, and then we're going to see another negative number. That positive plus those 2 negatives should be 0. That's the node law. This setup may look confusing, but it is designed in a way that you can take the 3 readings quickly. It's power into the high side of the circuit, through the series resistor, through the parallel resistors, and then returning to the power supply. The current amp meter low end goes to the top of the node, high end goes in succession. Replace this, then replace this, then replace this.
And all these values are supposed to add.
They should add to 0. You should get a positive current, that's the current going into R1. And then you get 2 negative currents, that's the negative leaving R2 and leaving R3.
Okay, gotcha.
So that's different from the voltage when we were measuring the voltage, where they should all be positive numbers.
Right. The difference really is just that sine flip. You could measure the voltage so that it adds up to 0. You could say the voltage here minus the voltage here minus the voltage here. Just means that the total voltage is the same as the total voltage. Really, it's this total voltage minus that minus that minus that should be 0.
So it's pretty much the same setup, but you're not utilizing the current.
The difference is when you measure the voltage law, the resistors are in series. When you measure the current node law, you have a series and a parallel.
So this is the whole lab experiment 6. That's it. Okay.
If you have your resistors in series, the current is a constant. You can measure it anywhere in the circuit, you get the same number. It's only when you have a parallel setup that the